almost 900 RPM. That's how hard it chops at fucking almost 900 RPM. Oh man, like a kid. Ow, my ear! Let's stay running. Recovered? Oh, recovered. Look at that. I'm working on it. And then working on the idle recovery and the idle. Getting something this big to idle on a factory ECU, fucking old O2 ECU, it's not fucking easy, man. Holy shit, it's taking a lot. It's doing good though. Like now it's pretty steady at 850, 900, right in that range. I mean, I think well, by the tack it's 800 to 900, just like in the software. Yeah, I'm pretty excited about it. Come on. Still needs mufflers, obviously. I'm actually excited to hear how quiet it gets with mufflers on it. I mean, I'm yelling to you right now, so it's not quiet. And it has cats in it. This is with cats. Woo. Yeah. Turn my phone to switch around, but it won't. Come on, phone. Phone's being stupid. Come on. There it goes. Jesus. Way harder than it had to be. Well, yeah, Aaron, it's a lot like that, actually. What? Yeah, it's fucking loud. But I'm happy. Cam I put in it is one that I designed. I say designed, but I guess I'm more like spec'd. You know, I didn't draw each individual lobe or anything like that. I went through a very large collection of lobes from DomCams. They have lobes in their published lobe profile manual, and then they have special profiles. And you got to ask specifically for the special Juju profiles if you want them, because they don't just publish them. So I asked very nicely, and they were very kind and gave me the special Juju profile spreadsheet, and I picked what I wanted. I wanted a very specific cam lobe, actually. I know that sounds crazy. It's exhaust lobe, because I know exhaust doesn't usually have a gigantic effect. Obviously, the primary lobe is the intake, but the exhaust has to match, and the exhaust has functions. And I know in some videos I've talked a little bit about exhaust gas blowdown versus expansion coupling and that kind of stuff. And with exhaust, you can do a little bit of both, and that's really tricky about exhaust lobes. With the intake, you want to have, for the most part, the fastest ramp rate possible. You want that valve to get open as quick as you can get it open, because that valve and the port is the restriction. The longer or faster you can get it open, the faster or more air you can get into that cylinder. So you want the intake valve to open as fast as you can get it open. I lost all my viewers, so I assume my video quality must be shit or something. I don't know. But yeah, so you want the intake to open as fast as you can get it to open. In almost all situations. And then how long you hold it open is up to you. But the sooner you get it open, the sooner air starts entering the cylinder. Like I said, since the port and the valve are technically a restriction, you think about, if I want to get air through an orifice, how do I get more air through an orifice? Well, I either make the orifice bigger, or I just let it happen for more time. And that's where the cam comes in. So you open that valve as fast as you can to get the orifice to be as big as it can be. And then wow, Jim, you the fuck out. I'll start again in a second. So you want that orifice to be as big as you can make it, which is port and valve opening. And then you want to have it open as long as you can, or as fast as you can get it to its maximum flow for as long as you can, right? Because you need to get air in the cylinder. When it comes to the exhaust side, it's a little different, because the pressure in the cylinder is used for a few things. It's used to push the piston down. That's obviously a given one. But then when the exhaust valve opens, that pressure is also used to push the exhaust out of the engine. And if you rely on just the upward movement of the piston to push the exhaust out, then you're not getting what's called blowdown. And blowdown means you open the exhaust valve early enough that the pressure of the combustion, the expansion combustion, starts forcing stuff down the ports and out the exhaust. So instead of the piston losing horsepower directly into the exhaust strokes, it's got to push it out of there, right? That expansion of the gas that you could have used towards making horsepower. However, the piston at bottom dead center isn't making a lot of power. As it approaches bottom dead center, that rod angle, right? The rod angle is changing, and it starts, like a TDC, it's all in line, right? And as it comes down, it does this number, and as it approaches the bottom, it starts to swing across, right? So you have all these degrees where the rod is swinging and the piston's pushing down, and you have these force vectors that are kind of pushing the crankshaft away from the direction that would make any good amount of horsepower, right? The angle now of the push is just no good. That's the best way of saying it, right? In the most layman's terms, right? Your force vector is not in a direction that facilitates the crankshaft moving, as efficiently as it does when it's further up in the stroke. So now I have this pressure in the cylinder. I can either couple that exhaust gas more and have it squeak every last little bit of energy you can out of it, or I can use that energy, that exhaust, that expansion, to start pushing exhaust out of the pipe. And if I use that expansion to do it, then the piston on the way up doesn't have to do as much work, because you're already starting to push it all down. And that's what's called blowdown, exhaust blowdown. So if you open that valve early, then you start blowing all that shit out of the exhaust, saving the work for the piston. So in some cases, and they say it also reduces back pressure. And and this one here be speculation, but I believe that they say it reduces back pressure because the gas that you need to get out of there now has more time to go down the pipe. Instead of the valve opening real quick and then the piston's got to push it all out, if I start it earlier, now it has time for all that to move down the port and out the exhaust. So I'm gaining power by having less back pressure. If it's already moving down, it's less back pressure. When the piston comes up, it's fighting less, right? There's less pressure fighting against the piston, and so you gain power in that way. So what I did is I chose an exhaust cam profile that had a very slow opening rate, but a very fast closing rate. So I went through all the profiles, and you can see like how many degrees it takes for the valve to get to a certain lift. Hey, buddy, how you doing? Neighbor's cat's here. His name's Max. He's freaking adorable. He's so nice. He's a little older, but he's just a lover cat. Come here, partner. Come here. Oh yeah, purring already. Yeah, this is Max. Say hi, Max. Can't get you in the frame. There you go. You might as well be my cat, but I don't feed him. So I chose a cam that has a slow opening rate. And so my idea was that if I have all this expansion happening, if I let it all out too fast, well, then I lose some coupling. But if I let it out a little bit at a time, then I gain some blowdown and I retain some coupling. So I chose one of the slowest, not slowest, but a relatively slow ramp rate on the opening. And like I said, in the spreadsheet, they show you how many degrees it takes for the valve to get to a certain lift. And with that, you can look and see what the approximate ramp rate is. So I chose one that had a very slow opening, but then a very fast shutting, because I want that piston to be near the top, pushing almost everything out, and then that valve to go at the last second and shut, right? So I chose a slow opening and a fast shutting. And with intake, it's quite the opposite, right? With intake, you want it open as fast as you can, and then shut as late and fast as you can. Which is what I did on the intake. I actually combined two profiles from two different series of lobes that they have. And like I said, it's their special Juju lobes, so you gotta like, you know, send them an email and ask nicely for their special top secret cam profiles. But they're the newer ones with the low shock technology type things, you know, where they set the valve down really just right, and you can run these suckers to higher RPM. They lose less horsepower than other cams and all kinds of stuff. So I picked the lobes out of that catalog, and then I chose their center lines. And you know, you can choose a lobe, but center line is also really important, because you gotta know when that piston's movement is that valve opening or shutting. And so to ensure that the piston is being chased down the cylinder by the valve as much as possible, you need to move the center line of the intake pretty advanced. And I think I chose 110 or 108. I don't recall, now I have to pull the sheet out. I think it's 110, which is fairly advanced for an intake profile that has 305 degrees duration, I think it was. So it's a big fucking cam, basically is what I'm saying. And then with the exhaust, I had that slow opening, but I delayed it a little bit. So I brought its center line at like 110, 108 also on the other side, which gave me a really tight LSA, lobe separation angle, and lots of overlap, which is what gives me the insane amount of chop. And if you haven't heard it because you just joined the stream, I'll go start it here in a second for you. It's pretty awesome. It's pretty awesome. I gotta get this cat off my lap first, though. Hi, buddy. Yeah, you're a sweetheart. Just a big sweetheart. Hey, James. And Jim, yeah, I'm sorry you're late, bud. That's all right. I'm gonna start it for you here. All right, buddy. Get down. He squawked at me. He's like, I don't want to get down. And I gotta start the loud car. Oh, come on. Come on, down. Oh, I know. Fucking hair off me. All right. Oh, he doesn't follow me. He won't like what's about to happen. Phone around, if it will. Sometimes it's super. There it goes. You better go away, Max. It's gonna get loud. All right, here we go. care. That cat's so fucking chill. The valve train is so quiet, I can't believe it. I got gear drive timing on it and I can't hear it. I'm honestly a little bummed out. Yeah, I can't even hear it. I was hoping it'd have a little bit of whine to it. I wanted to have my super spooler, my pretend supercharger, make people think it was supercharged with the whine, but there's no whine. That's the DomCam's gear drive timing. I'm pretty sure they got it from a place in Australia. I think they bought the design from a place in Australia that did them. Look at this cat. Ears are slightly bagged. We don't care otherwise. Getting this thing to idle was difficult. I had to pull way more fuel than I thought I would. I had to pull like 20% fuel out of it at idle. Even though I had a cam and the big manifold before, and I added displacement, I still had to pull 20% fuel out to get it to stay idling because it was just too freaking rich, which is just insane to me to pull that much fuel. My VE now is like 40%. It idles at 75 kPa. I mean, I'm almost atmospheric on this thing. Watch out, Max. So anyways, did he stay? No, I didn't think so. I figured he would run from that. That's too loud. Sorry, buddy. I thought I was shooting at him. Not. Anyways. So my goal with this car, at one point, I started building an engine with forced induction in mind. And the blower kit I got turns out didn't even freaking fit because it was actually for a C6, not a C5. And turbos are just expensive and hard to find places to put. So I said, you know what? Fuck it. Let's just make a really high RPM, absolutely stupid sounding V8. I think I succeeded. It sounds fucking retarded. So that's good. I'm pretty happy with that. And everything is built to rev to like 9. The only thing in the engine that I would say would limit it from doing that or more than that would just be the lifter bore size, because it's factory LS lifter bore size. And when you get a lot of valve, well, maybe the valve springs too. The valve springs might be limited to that. You get a lot of pressure on them. Then, I mean, think about it. The lifter sits in the bore. The push rod goes into that, and it goes to the rocker. Well, the angle from the push rod to the lifter is not directly in line. There's a slight skew to that. And so that skew means, again, there's a resultant force vector. I got one going this way, one going that way at a slight angle, and you get this little bit of a vector in the opposing direction. Come on, buddy. Fire planes just flew overhead. The local airport's been a hub for all the fire planes. So, I mean, there's tons of fires right now. Look at this stuff. Come on. Sorry about that. Sorry, look at all the smoke. Yeah, it sucks. Anyway, so you get a little resultant vector that pushes the lifter into its bore, sideways into its bore. And then as that force gets higher and higher, the surface area of the lifter and the bore is not large enough. You know, it's not necessarily even that the oil, not enough oil there. I mean, there is enough oil there because there's not enough surface area to distribute the load evenly. So as you bump that RPM up, it's going to start having problems. So I'm going to rev it as far as the valve springs will let me take them. And then and that's it, I think. That's what I'm going to do. So I have a shift light set on it for 7,500 right now because the factory Corvette tack only goes to 7. So I got the shift light set at 75. It lights up the normal shift indicator on the dash. And then, yeah. So obviously I get it on the dyno. I got to see what it does on the dyno before I even know if I should be revving it that far. You know, that cam may fall on its face, or the engine, or the ports, or who knows what you know, what limit I may find. And it may just fall flat, you know, at 6,500. So I have no idea of knowing what it's going to do because no one's put these two profiles together. No one's done this cam the way I did it. So I'm excited though. You know, I don't really know. Someone asked what the horsepower goal is on the car. That's the thing about NA. Right? Like, it's hard to have a horsepower goal when you're NA, because things just make what they fucking make. I mean, you know, when you're building an NA engine, and this is something that the turbo 4-cylinder scene often completely misses or doesn't even know it exists, and it's something that you know, domestic guys have known forever, right? And that is the parts that you buy, they got to match. You know, when you buy something, it tells you the approximate RPM range that it's good for. Well, there's a reason for that. Man, this fucking fly is just bugging the shit out of me on my leg. There's an approximate RPM range that these, you know, these things are good for, and you have to put those together. You get a cam that's a certain size. I can't hear my nose itches like crazy. You get a cam that's a certain size, and it's so big that you need to have a bigger intake manifold plenum to help absorb the impulse of that cam opening up and the strength of the pulse that you get in the manifold, but also to be able to supply enough air to that port and feed the engine. And so one of the things that I did when I started MPS was trying to educate people on balance. That balance, when you're building a 4-cylinder, it's the same freaking thing. You got to have the right size exhaust, you have this right intake manifold, you got the right turbo, the right cam profiles, you know, compression ratios, bore stroke ratios, you know, all of that stuff. I tried to bring that to the turbo imports, you know, scene with a lot of the products that I was making. And I think that I was relatively successful at that initially, which is why I think that, you know, my name got out quite a bit in 2006, 2007 timeframe for the stuff that I was doing. I think that helped, right? Bringing that to the scene helped out. Trying to educate guys and to understand that, oh, well, you don't just buy this gigantic cam and put a VF turbo on it, right? That just doesn't work. Those things, that they're not balanced, they don't match. And when you do build an engine with a specific goal, or sorry, a certain, okay, thank you. Sorry, phone's blowing up. With a certain level of balance, you can get really crazy results. Like Josh's car, I built everything for like 4,500 RPM, really, and it ended up making like 650 plus foot-pounds of torque, just over $4,000. It was ridiculous how much torque it made. And then in the next iteration of the build, I adjusted some stuff to try and knock that torque down a little bit and broaden the power curve, and I did. But if you get everything to be efficient and effective in their sweet spots at the same point, you can get huge gains in that region. If your compressor map is efficient, if your cam profile is correct, if your cam timing is correct, you know, the ABCS, or if you can have that option. Like, I don't have option for cam timing on the Vet. I gotta do that in the cam profile from the beginning. If those things are all in line, right, everything's reaching efficiency at the same point, you're gonna get huge gains in that specific region. And you can also choose to mismatch the shit out of it to just have kind of a broad curve that's not spectacular anywhere, right? I mean, those are the options that you have. You can choose, one area that everything is just super strong, where you see cars that make 1,000 wheel horsepower, and there's like nothing, and it just screams up, and bam, 1,000 horsepower. Well, everything was efficient right there, and below that, nothing was efficient. So there's a lot of that in building a car, and so with an NA car, you do what you can in getting those things all to match, but it's going to make what it makes, um, there's no volume knob. I can't just add air like you can with a turbo. I can't go, oh, I didn't do it. Let's change the turbo to a different one or whatever. You don't have that. So my goal was as much as I could get, right? As much as I could get, still be able to run pump gas and have it sound just plain stupid. And, well, it sounds just plain stupid. It's 11.2 to 1, I think, was the compression, if I remember correctly. So I can barely run it on pump gas. I have good exhaust on it, good headers. I got one of the biggest manifolds that you can get. Actually, I also have the BTR eliminator or equalizer, whatever it's called. I have that too, but that one only makes power over like 6,000 RPM, and I wanted a little bit of mid-range to it, so I stuck with the fast LSXR manifold. But hey, if I find that the power curve is not the right shape, I might throw the BTR on it and then sell the fast. But I have a feeling I'm going to end up selling the BTR and keeping the fast. This fucking cat. What do you want, buddy? You can't possibly be pets, right? I know. You're cute. So, anyways, yeah, my goal was as much as I can get. So I have CNC ported heads, with a flow profile that I liked, that I felt matched what I was doing with the cam. I tried to get everything to match pretty well. And it's not going to be a 10,000 RPM screamer. I think, it's going to be 8,000 RPM screamer, I think. Organization for a big block build for towing. Do you mean like old school big blocks? Because if that's what you mean, I don't. I would say get something else, I guess. I don't know. It's that's a weird thing with big blocks because they're so inefficient. It's just the port design is shit. It's all just so inefficient and focused around just having everything big, and by today's standards, there's so much stuff that you can do without just necessarily going big. And when you're towing, I don't know. I think economy is important when you're towing. I think the ability to get good fuel economy when it's not loaded heavily is important. Because towing usually implies you're going a distance. Right? Because if you're going a short distance, who cares what fucking power it makes? Just drag the thing there as best as you can. But if you're building something for towing, that means you're doing it with the intent of trying to get as far as you can, or go a long distance with it. And that's where economy comes in. So that's why towing is kind of a weird thing. Anything better than 10 empty? Yeah, I mean, my Duramax she's a big bitch, right? It's a dually, 1-ton, quad cab, just a big truck. And I get 15 in that on the highway with nothing. And then I get 14 towing with a fully loaded 12,000 pound trailer. Like, it just doesn't care, like 1 mile per gallon drop and that's it. Unless we hit like some serious passes, then of course, as with anything, the economy drops a lot. So that's really good to me, right? That seems really good to me. But gassers are going to be, especially big block gassers, potentially in the single digits, and that's not okay with me. I don't think I could do that. Now, BTR Brian Tooley Racing, they have a really sweet cam for LS truck-based motors. They have 3 torque cams, and even the initial one, the high torque cam, they have 3 torque cams. The torque cam is super impressive. That thing is extremely impressive. Makes a lot of torque, and runs really well, and has decent economy for a big cam like that for a truck. So if you're doing something LS based, that cam is really, really good, and that's the best recommendation I can give you in that. Because other than that, you want to have an intake manifold with the longest, skinniest runners you can get for the most torque. You want to have an exhaust manifold, you know, that's got longer, whether it's the headers or, you know, or whatever. You want to have, you know, a balanced exhaust. You don't want to have any back pressure. Whoever says back pressure is needed for torque is fucking stupid. That's not at all the case. It's never been the case. So, you don't want any back pressure. Doesn't mean it has to be loud, right? But you don't want any back pressure. Banks exhaust. Can't hear anything? Well, I apologize. I don't know what to do. Are you just deaf from before? Or did my car pick up my phone? No, everything seems fine. Yeah, so my phone is on fire. It is literally burning my hand to hold it right now. Oh, I could have been. I don't even know what the fuck the mic is on this thing. It's a Pixel 5. I think there's like a bunch of them. Sorry. Yeah, so my phone's burning my hand now. I can't keep holding it. It's actually like really hot. It's probably melting down. I have an app that's telling me the battery temperature, but I have to leave the video to check it, I think. But I'm sure it's really high. Anyways, wife's coming home. I need to clean some stuff up. And I'm going to work on the car some more. I got to get ready for this weekend. I'm supposed to go to a meet this weekend. And go downtown. I need to get the exhaust done before then. Because this is just too loud. Because I'm too old. I kind of want to go straight exhaust like this and just see if the cops do anything. Because the hypocrisy of law enforcement with imports and domestics, it exists. It fucking exists. There is domestic privilege, let me tell you. Systematic domestic privilege. It exists. And if you have a Subaru, it's just terrible. The cops pick on you. And actually they do. The cops do pick on you. I've had some cops totally admit that they target Subaru guys. So, yeah, so domestic privilege is a real thing. And I kind of want to go and, you know, use my domestic privilege and run straight pipes down Main Street of Coeur d'Alene and see if anyone gives me a hard time. So maybe I'll do that. I don't know. Regardless, I got to get tips turned down because they're blowing on my tranny mounts, and I don't want to melt my transmission mounts with hot exhaust gas. And I may have already hurt them a smidge. We'll see. I'm going to go in there and take a look. But I at least need to get the tips turned down. So, yeah, if I record it. I mean, record what? The cops not doing anything? Or just me driving downtown? Run by them, give it a rev, wave. I don't know. I mean, it's only like 12 miles to downtown Coeur d'Alene from here, but I might need to wear earplugs. Because it's fucking loud. Anyways, I keep looking at that cat because he's just so fucking hilarious. All right, I am dropping a lot of F-bombs today because I'm excited. And that kind of happens, you know, when you get excited about stuff. So I haven't been excited about anything in a while. And so that's one of them. This is one of them. I guess thanks for stopping by, guys. I'm going to go and work on the car some more. See if I can figure out something for dinner. If the wife's on her way home, maybe she'll think that I was being super thoughtful or something. Usually I just say, well, what do you want to make? I'm just kidding, I don't say that. But that'd be funny. I'm sure I'd get brownie points if I said that, right? She just gets home from work, I'm at home all day, fucking around in my car. She comes home, I'm hungry. Good, what do you feel like making, sweetheart? I wonder how nice I could say that and how little of a dirty look I could get. Like, how nice could I say that without getting like the worst freaking look ever, you know? What do you want? Honey, I want whatever you want to eat. Whatever you want to make is what I'll eat. Oh, shit. That'd be fucking hilarious. Maybe I'll try that when she gets home. And maybe my next one will be, I'm getting divorced. All right, guys. Well, thanks for stopping by. Have a good day.